Nenomatica, where mathematics meets YouTube excellence. In this mini lesson, we will simplify three expressions with radicals and exponents step by step and explain the rules we use along the way. Here are the three expressions we will simplify. First, the fifth root of 2 to the 10th times 5 to the 15th. Second, the 12th root of a bc multiplied by the 12th root of a squared b to the 5th c to the 8th. Third, 5 times the cube root of 64 minus 4 times the fourth root of negative 5 to the 4th. Example 1. We start by using the product rule for radicals with the same index. That lets us split the product inside the fifth root into a product of two fifth roots. Next, convert each radical to a rational exponent and divide the exponents by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. Finally, compute the powers. 2 squared is 4, and 5 cubed is 125. Multiply to get 500. Example 2. Multiply two 12th roots. First, combine them under a single 12th root using the same product rule. Now add exponents for like bases inside the radical. 1 plus 2 makes 3 on A. 1 plus 5 makes 6 on B. 1 plus 8 makes 9 on C. Each exponent is a multiple of 3, so factor out a common 3. That is, a to the 3b to the 6c to the 9 equals open parenthesis, ab squared c cubed close parenthesis to the third. Convert the radical to a rational exponent. 3/12 simplifies to 1/4. So the result is open parenthesis, ab squared c cubed close parenthesis to the 1/4, which is the fourth root of ab squared c cubed. Example 3. Simplify 5 times the cube root of 64 minus 4 times the fourth root of negative 5 to the 4th. Start by rewriting 64 as 4 cubed, and notice that negative 5 to the 4th is a perfect fourth power. Apply the nth root of a perfect nth power. The cube root of 4 cubed is 4, and the principal fourth root of 5 to the 4th is 5. Here is our example, and the first expression to simplify. Rule reminder. Nth root of a to the m equals a to the power m over n. We'll apply it as needed while carefully rewriting each radicand as a power of 2 and removing negatives raised to even powers. Step 1. Because the exponents are even, the negatives disappear inside those radicals. We rewrite the numbers using simple powers. Step 2. Express 4 as 2 squared and 8 as 2 cubed. Now apply the rule nth root of a power equals a to the power m over n. Here, 2 over 6 for over 12 and 6 over 18 all equal 1/3. So each of those three radicals becomes a cube root. Step 4. Combine the factors under a single cube root. 4 times 2 times 2 times 2 equals 32. The cube root of 32 is the cube root of 8 times 4, which equals 2 times the cube root of 4. Great, cube root. 4 times 2 times 2 times 2 equals 32. The cube root of 32 is the cube root of 8 times 4, which equals 2 times the cube root of 4. Great. Now, we tackle the second expression. Watch for the exact same pattern. Again, we will rewrite each radicand as a power of 2, then convert to fractional exponents. Step 1. Express each number as a power of 2. Note that negative 16 squared becomes 2 to the 8th. Step 2. Convert each radical to a fractional exponent. Each fraction simplifies to 1/2. Add the exponents. 1/2 plus 1/2 plus 1/2 plus 1/2 equals 2. So the product is 2 squared, which is 4. Quick recap. We matched the exact step order. 1. Removed negatives inside even powers and wrote bases as powers of 2. 2. Converted each radical to a fractional exponent. 3. Simplified the fractions. And 4. Combined like factors. Exponents. 1/2 plus Example. We will simplify the radical product. Step 1. Express every number as a power of 3. Now simplify powers that are inside the roots using the power of a power rule. Convert each root to a fractional exponent. Since the base is the same, add the exponents. The sum is 1, so the result is 3. Great job! Example. Now simplify the product with cube and sixth roots. First, because the exponents are even, the negative signs disappear. Rewrite the radicals as fractional exponents. Reduce the fraction 4 over 6 to 2 over 3. Express 4 as 2 squared. Use the power of a power rule. Add the exponents because the base is 2. Finally, evaluate 2 squared to get the answer. Nicely done. Summary. We converted radicals to fractional exponents, simplified powers inside radicals, used power rules, and added exponents for the same base. We will simplify the fraction. The 7th root of 7 times 10 to the 7th divided by the 14th root of 49. Next, step 1, rewrite the denominator using exponents. Step 2, convert the denominator to a 7th root using fractional exponents. Step 3, since the index is the same, combine as a single 7th root of a quotient. Step 4, the 7th root of 10 to the 7th equals 10. Great. The simplified value is 10. Now for a quick challenge. Before I reveal the next step in the second example, try to predict the move. Second example, we will simplify a fraction of radicals with variables. Step 1, multiply the cube roots in the numerator. Step 2, convert the 6th root and the 9th root to equivalent cube roots. Step 3, multiply the denominator's cube roots into one cube root. Step 4, combine the single cube roots as a quotient under one cube root. Step 5, simplify exponents and finish. Time for a quick recap. We'll summarize the key ideas and the final answers. We show the word example. Then we display the first expression. And here is the second expression we'll simplify next. Now we begin with the first expression. Recall the key rule for radicals and exponents. The nth root of a to the m equals a to the m over n. We rewrite 25 as 5 squared and convert the 8th root of 5 squared to a 4th root of 5. Next, we multiply inside a common 4th root. A 4th root of 5 to the 4th simplifies to 5. Quick check. Why did the 8th root of 5 squared become the 4th root of 5? Because 2 over 8 equals 1 over 4. Let's simplify the second expression. We again use the radicals, exponents bridge, and convert every factor to a 4th root. Write each fraction as 2/5 to a power, noticing that negative 2/5 to the 8th equals 2/5 to the 8th. Convert all indices to 4th roots. Combine the 4 identical 4th roots into 1. Finally, the 4th root of 2/5 to the 4th equals 2/5. The word example appears. Then the problem statements in bold orange latex. First expression to simplify is square root of a to the 4 plus b to the 4 times the 4th root of a to the 8 plus b to the 8 plus 2a to the 4b to the 4. Step 1. Recognize a perfect square under the 4th root. We rewrite a to the 8 plus b to the 8 plus 2a to the 4b to the 4 as the square of a to the 4 plus b to the 4. Step 2. Convert the 4th root of a square into a square root of the base. Step 3. Multiply the two equal square roots and combine them under a single square root. Step 4. Recognize the product as a square of a to the 4 plus b to the 4. Step 5. The square root of a square simplifies to the base. We obtain a to the 4 plus b to the 4. Now, we follow the same exact structure for the second expression from the image. Our second expression is the cube root of 6 over 50 root of 6 over 54 times the 6th root of 1 over 9. Step 6. Replace 1 over 9 by 1 over 3 squared inside the 6th root. Step 7. View 1 over 3 squared explicitly as the square of 1 over 3. Step 8. The 6th root of a square equals the cube root of the base. Step 9. Multiply cube roots by combining the arguments under a single cube root. Step 10. multiply the fractions inside the cube root. 6 over 54 times 1 over 3 equals 6 over 162. Step 11. Reduce the fraction by dividing numerator and denominator by 3, giving 2 over 54 inside the cube root. Quick challenge. Can you Example. Here is our first expression. Step 1. Combine products that share the same index. For the cube roots, multiply inside a single cube root. For the ninth roots, multiply inside a single ninth root. Step 2. Notice the cube root now contains a product raised to the second power. We can rewrite it as the square of the product. Step 3. Recognize the factorization. The quantity open parenthesis, a minus b close parenthesis times open parenthesis a squared plus a b plus b squared close parenthesis equals a cubed minus b cubed. Step 4. Convert the ninth root to an exponent and simplify. Exponent 3 over 9 equals 1 over 3, which is a cube root. Step 5. Multiply cube roots. One cube root times another equals a single cube root of the product. Quick challenge. Could you predict that final combination in step 5? Take a moment to think about products under the same radical index. We will simplify a nested radical expression using a clean, rule-based approach. First, we present the problem statement. Then we go step by step, showing the rule used before each algebraic move. Step 1. Combine terms inside each radical so that every radicand is a single fraction. We use the idea that a square root of a sum can be organized to prepare for completing the square. Now we show the rule box and then the algebra line. Step 2. Recognize perfect squares in each numerator using the completing the square pattern. We display the rule, then write the expression as squares. Step 3. Take the square root of a quotient. This introduces absolute values in the numerator. Show rule. Then simplify each radical. Step 4. Combine the two fractions since they share the same denominator. Show rule box. Then form one fraction. Step 5. Remove absolute value box. Then form one fraction. Step 5. Remove absolute values by considering two cases depending on the sign of square root of a minus b. Show rule box for absolute values. Then write both cases explicitly. Step 6. Simplify each numerator and reduce. This yields the final piecewise answer. We show the rule relationships and then the final simplified cases. Quick challenge. Can you predict the next steps to simplify a product of radical powers? Take a moment to think before we continue. Now, a second example involving fractional exponents and roots. We begin by presenting the problem and then simplify step by step. Step 1. Move the power inside each radical. Show the rule, then rewrite. Step 2. Simplify the even power of -2 to 4, which equals 2 squared. Then substitute into the radicals. Step 3. Convert the sixth root to a cube root to match indices. Show the rule idea of -2 to 4, which equals 2 squared. Then substitute into the radicals. Step 3. Convert the sixth root to a cube root to match indices. Show the rule idea, then rewrite with common index. Step 4. Multiply radicals with the same index by multiplying the radicands. Then combine inside one cube root. Step 5. Take the cube root of 2 cubed to get 2. That is our final value. To summarize, we grouped radicands, completed the square, handled absolute values with cases, and thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.